Okay, 3.7. I'm going to do the ones that were assigned and a few other ones just to help you out. The whole point of this one is to look at the multiplicity of x-intercepts, which come from the numerator, and multiplicity of vertical asymptotes, which determine the behavior at those asymptotes. So this would go straight through at an x-intercept and have opposite directions for the curve at a vertical asymptote. This one has same direction, this one has opposite direction, and this one has straight through x-intercept, which matches. This one has a bounce at x-intercept, which that matches, but it has opposite directions at the vertical asymptote because it's a single multiplicity. So this one, 2, must be B. Bounce it at some place and opposite direction. This is straight through and squared in the denominator at this here. So a square in the denominator and straight through in the numerator. That looks like the one you're supposed to be doing, A. This one bounces at the x-intercept, so it's got to be a square in the numerator, and goes in the same direction in the denominator, so it's got to be squared in the denominator. So 4 goes here, opposite direction, so it's a single in the numerator or denominator, and straight through in the numerator, so it's single and single, which is 1. 1 is D. This is A, this was C, and this was B. That's just what you're supposed to be looking at here. So this one, horizontal intercepts are x-intercepts. They're on the horizontal axis, intercepts. And the vertical intercept is a y-intercept if you have x and y. If you got different variables, then we would just call them vertical and horizontal. Vertical asymptotes are the lines that it approaches, which are determined by denominators, and horizontal asymptotes determined by degree. X-intercepts determined by numerator. There's no x's in the numerator of 8, so there's no x-intercepts or no horizontal intercepts. Vertical intercepts, you put in 0 for x, and if you put 0 in for x, you get 5 over 1, which is 5 for the r or y. And vertical asymptotes, whatever makes the denominator 0, which looks like x being -1 will make the denominator 0. So that's a vertical asymptote. And the horizontal asymptote is determined by degree. If the degree, which is 2 in the denominator, 0 in the numerator, if the degree in the denominator is bigger than the numerator, the thing goes to 0. So the horizontal asymptote is y equals 0. Okay. If I were to do this one, I'd have to factor the numerator and factor the denominator, and I could do that using Desmos. Just graph that only if you're not good at factoring. Let's just do it here. This is 2x and x, and if I do 2 times 5, that's 10, and 5 times 3 is 15, so 10 minus 3 is 7, so I got to do plus 10 minus 3x to get 7x, and a minus and a plus make 15. So that's how that factors. This factors to 3x and x. We hope it factors here. And if I do 3 here, I get 9, and 5 here, I get 5. And if they're both minus, I get a plus 15 and I get a minus 14. Minus 9x minus 5x minus 14. And minus 5 times a minus 3 is plus 15. There's no matching factors, so there's no holes. So x-intercepts, what makes this be 0? That would be -5 would make 0. And if I set this equal to 0, I guess this would have to be 3/2, because the 2 would cancel, make 3 minus 3, 0. 3/2 will make 0 in this one. You can get that by setting 2x minus 3 equal to 0. Add 3 to both sides. And divide by 2, and you get 3/2. So x-intercepts, y-intercept. If I put in 0 for x, I get 0, 0, minus 15, 0, 0, plus 15. Minus 15 divided by plus 15 is -1. And vertical asymptotes. So that would happen when this is 0 at x equal 3. And when this is 0, so if I set 3x minus 5 equal to 0, add 5, divide by 3, x equals 5/3. X equals 5/3 is also a vertical asymptote. Vertical asymptote there, and vertical asymptote there. X-intercept makes that 0. X-intercept makes that 0. Put in zeros for the x, I get the y-intercept. And define the horizontal or oblique. We look at the degree. Same degree. So not like this one where the degree of the denominator is bigger than the numerator. It goes to 0. This one, they're equal, and so it goes to the ratio of the leading coefficients. In front of the leading coefficient here is 2, leading coefficient here is 3, so it's 2/3. This one, same degree, so the horizontal one is going to be y equal 1 over 1 or 1. This factors to x minus 3 and x plus 2. So x-intercepts are 3 will make it be 0. -2 will make it be 0. There's the x-intercepts. Y-intercept, I put in 0 for all the x's, and I get -6 over -4, which is 6 over 4, which reduces to 3 over 2. So if I put in 0 for x, I get 3/2 as the y-intercept. X-intercepts, y-intercept. Oh, wait a minute. What's this denominator factor to? X plus 2 and x minus 2. There's a little slight here. These factors are the same, so this is not an x-intercept because there's a hole. And so there's not a vertical asymptote at -2 because that's where there's a hole. So there's only a vertical asymptote at x equal 2. Vertical asymptote because of this, not there because that's a hole. X-intercept at 3, but not at -2 because that's a hole. And everything else stays. If you were interested in where the hole was, we would do the reduced form, which is x minus 3 over x minus 2. Using the reduced form, we'd put in the holes at -2. So we'd put -2 in, and we get -5 over -4. So there's a hole happens at -2 for the x, and its y coordinate is the negatives cancel, and at 5/4 or 1 1/4. Okay, this one. I'm running out of room here, so let's pull a piece of scratch paper here. Numerator factors to 2x and x. To come up with minus 3, I better have 8 and 5. 4 times 5 makes 20. So if I put 4 here, I get 8 and 5x and 8x, and I want to subtract them, and that's good because that's minus, so one of them is negative. And we get more minuses. So minus 8 plus 5. That's the numerator. The denominator is x minus 5. So, x-intercepts. Well, what makes this 0 is 2x plus 5 equals 0. Subtract 5, divide by 2, x equals minus 5 halves. So minus 5 halves will make 0, and 4 will make 0. Neither of these match, so there's no holes. Vertical asymptote is when x is 5. Y-intercept, put 0 in for x. That's easier here. That's minus 20 over minus 5, which is 4. And vertical asymptotes and horizontal asymptote, the degree of the numerator is 1 more than the denominator, so I got to divide this into this. I'm going to do that 2 ways. I got to divide this into that. I can do it long division. X into there is 2x times x makes 2x squared. 2x times negative 5 is negative 10x. Draw the line, change the signs, add like terms, and I get 7x minus 20. X into that is plus 7, and there's my equation of the oblique asymptote. Y equals 2x plus 7, but I'll continue on. 7 times that's 7x. 7 times negative 5 is negative 35. Draw the line, change the signs, and I get 15 plus 15 divided by x minus 5. But as x gets very large, this denominator will get big compared to the numerator, and this will go to 0, so that's why this is what the curve gets closer. This is not 0, but it gets closer and closer to 0, and so it gets closer and closer to that line. So that's why that's the oblique asymptote. Now, since this is a simple factor as opposed to, say, something like this or something like that or something like that or whatever, I could do this one by synthetic division. I could say 2, negative 3, and negative 20, x squared, x constant. Synthetically, what makes this be 0 is a 5. 2 plus 0 is 2, times 5 is 10. 7 times 5 is 35. 15, so I get 2x plus 7, same as I had here, plus 15 over what I was dividing by, x minus 5. This part goes to 0 as x gets large, and this becomes the oblique asymptote. Okay. Let's do 18. X, let's see, is there any factors that match? Nope. X-intercepts. negative 2, 0. And if I want, I could say this is going to have a multiplicity of 2. And at 5, 0. So this would bounce. This one goes straight through. Those are the x-intercepts. Y-intercept means I got to put 0 in for x, and I'd get 2 squared 4 times negative 5 is negative 20. 0 in for x is here, and I get negative 3 times 1 is negative 3 times 4 is negative 12. The negatives cancel. 4 goes into both, and I get 5/3. That's the y-intercept. X-intercept, setting that equals 0. Y-intercept, putting 0 in for x. Vertical asymptotes is when the denominator is 0, so that's at x equal 3. That's the equation of a vertical line at 3. X equal minus 1, and x equal negative 4. And the degree of the numerator is 1, 2, 3, and the degree of the denominator is 1, 2, 3. And so the horizontal, it's a horizontal asymptote because the degrees are equal. In fact, it turns out to be y equals the ratio of the leading coefficients. This would be 1x to the third. This would be 1x to the third. So it's 1 to 1 or 1. Okay. Page 2, number 20. Now we're reversing the process. What if we know there's a vertical asymptote at x equal negative 4? That means the denominator has x plus 4. If it's at minus 1, that means x plus 1 must be in the denominator. X-intercept of 1 means x minus 1 has to be a factor in the numerator. At 5 means x minus 5 also has to be in the numerator. And these are equal degree right now, and so there's a number here. And when I put in 0 for the x's, I'm supposed to get 7, so I can solve for a by doing that. So 7 equals a times, if I put 0 there, I get minus 1. 0 there, I get minus 5. Minus 1 times minus 5 is 5 over putting a 0 in for the x's. I get 4 times 1, which is 4. To solve for a, this says divide by 4, so I'm going to multiply by 4. This says multiply by 5, so I'm going to divide by 5. And I get 7 times 4, 28 divided by 5. A equals 28 divided by 5, which is 5.6 or 5 3/5 or 28/5. That would go here, and that would be the final equation. So 24. Vertical asymptote at 3 means the denominator has x minus 3. Double 0 at 1. So that means x minus 1 is squared. And they didn't tell us the behavior there, so we're just going to leave it single. It's going in opposite directions, and there's an A. And the degree is higher in the numerator than in the denominator right now. But we're not going to worry about that. It would be an oblique asymptote, but it's got to go through 0, 4. So if I put in 0, I'm supposed to get 4. 0 is minus 1 squared is 1. 0 minus 3 is minus 3. And so to solve for a, this says divide by negative 3, so I'm going to multiply by negative 3. And it says multiply by 1, so I divide by 1. And so I get negative 12 is a. And that meets these conditions. There are other possibilities, but that meets the conditions. Okay, 28. Now instead of telling us equations or conditions, it shows us conditions. So y equals vertical asymptote at minus 3, so it's x plus 3. Going in opposite directions, so this could be 1, 3, or 5, or 7, or whatever. We'll go simple 1. Vertical asymptote at 4 means x minus 4. Going in the same direction, so it's got to be even. We'll just do 2 for even. And x-intercept. X minus 2 makes an x-intercept at plus 2. Looks pretty much like it goes straight through, so that would be degree 1. And if the numerator's degree is higher than the denominator degree, it will go to 0, which is what appears this goes to in the long run. The end behavior is headed towards y equals 0. And if it is, there still may be an a here. And we have a y-intercept of 0, 1. To make that happen, I put 0 in for all the x's, and I'm supposed to come up with 1. 1 if the x's are 0, so we get a times negative 2 over 0 minus 4 is minus 4 squared is 16 times 3 is 48. That reduces to negative 1/24. To solve for a, I would multiply both sides by negative 24. And so a becomes negative 24. That would go in place of the a, and we'd have our equation. Okay. 31. Looks like it's going towards 0, so the numerator and numerator degree is less than the denominator. But let's look at what we have for factors. So y equal, denominator must have a factor of x minus 3, or x plus 3. And it must be at least 1 or 3 or 5. And it must have x minus 2. And its degree, since they both go in the same direction, has to be 2, 4, 6. We'll go the simplest. And it has x-intercepts at 1. And it bounces, so it's got to be 2. And to go to 0, the degree of the denominator has to be more than the numerator, and right now it is. So this looks pretty good, except we got to figure out the constant. And it looks like it goes through 0, negative 1/2. So negative 1/2 times, it would have to equal a times, if I put 0, they get 1. Put 0 in here, and I get 4 times 3, which is 12. And so I multiply both sides by 12. And a equals 12 times negative 1/2, which is negative 6. (31). 36. Now, the only way we get a horizontal asymptote that's not 0, and not oblique is if the degree of numerator and denominator are the same. And when that happens, -1 is what is times everything. So we got the leading coefficients, -1 and 1. And the vertical asymptotes, there's one at -3. And it happens probably once because they go in opposite directions. And there's one at 1. And probably 2 because they go in the same direction at that asymptote. And we have x-intercepts. It looks like there's only one at -1. So it's x plus 1. But this is not at 0, which would mean the degree of the denominator is bigger than the numerator, which is what we have. It's at -1, so the degrees have to be equal. And so this must be cubed. It is odd, and it must be cubed. It must be hesitate and go on down. So that must be the equation. And again, you can type these in and look at the graph and see if they match. Okay. 38. We've got a horizontal asymptote that's at +1. So it's A over B has got to be 1. And the degrees have to be equal. And we have a vertical asymptote at -1, so x plus 1. And x at intercept of 2, so it must be x minus 2. Degrees are equal, goes horizontal asymptote of 1, but we have a hole. Holes are caused by same factor in the numerator and denominator. To have a hole at 4, it's got to be x minus 4 and x minus 4. If I ever wanted to know the y-coordinate of the hole, I'd put 4 into the reduced form. That would be into here. So 4 minus 2 would be 2, and 4 plus 1 is 5. So the hole's at, and times 1 is at 2/5, or 0.4. (42) To be an oblique line, the degree of the numerator has to be 1 more than the denominator, which it is here. 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 And it is here. 2 to 1. 3 to 2. And if it's oblique, you divide the denominator into the numerator. So we've got 2x plus 1 to divide into, put them in order, negative 2x squared plus x plus a 5. 2x times what makes negative 2x squared? I think that would have to be a negative x. Negative x times 2x is negative 2x squared. Negative x times 1 is negative x. Draw the line, change the signs. These will cancel, and we get x plus x, 2x plus 5. 2x times 1 will make 2x. There'll be a remainder, plus remainder. We don't care because that's going to 0. And the oblique asymptote is y equals minus x plus 1. It has a slope of -1 going through +1. You can graph the original and graph this, and you'll get a picture of it. Now, if I take 1 times this, I get 2x plus 1. Draw the line, change the signs, and I get 4, and we get plus 4 over 2x plus 1, but this goes to 0 as x gets large, and so that's the oblique asymptote. 44. Not factored, so we don't know anything about it, but the degree here is 1 more than here, so we do long division. Let's pull up a piece of paper here to do that on. So I'm going to do x squared plus x plus 1 into 2x to the third plus x squared plus x squared times x makes x to the third, and times a 2 will make 2x to the third. And 2x times x is plus 2x squared, and 2x times 1 is plus 2x. Draw the line and change the signs. These cancel, plus 2x cubed minus 2x cubed. 1x squared minus 2x squared is minus 1x squared. Minus 1x, because that's 1x, and minus 2x is minus 1. X squared times a negative 1 will make this. And so y equals, that's the oblique asymptote on that one. "45. Scientist has a beaker, a Pyrex glass container, that has 20 milliliters of an acid solution, which is 20% 1/5 acid. So if this separated out, we could divide this into 5 layers, 1, 2, 3, 4, 5, 5 equal layers, and one of them would be the acid. Now, of course, they're mixed, but we're going to imagine it separated. And so 1/5 of 20 is 4. So there's 4 milliliters of acid in 20 milliliters of water. So if you wanted to figure out the percentage acid, we'd do 4 milliliters divided by 20 milliliters, and 4 divided by 20 is 0.2, or 20%. Now, they're saying she's going to add pure water. So now this will have the same amount of acid, and it'll have a solution that's 20 milliliters, counting the acid, plus n milliliters more of water added to it. So it's going to be 20 mLs of acid and water plus n milliliters of water. No more acid, so I'm not adding anything here. And so this would be the concentration based on the number of milliliters of water added to the whole thing. Now, the units in here make it a little confusing. I'm going to pull them out so we can see that this is very much like what we've been doing. This has a vertical asymptote at negative 20. If I took 20 milliliters of water out of here, I wouldn't have any solution. It also, as n gets very large, this fraction will get very, very small. So it has a vertical asymptote at negative 20, but we can't even go there. And as we get bigger and bigger, it goes to 0. And if we don't add any, the percentage is 20%. So that's the y-intercept, 1/5. And then it gets smaller and smaller percentage as we go out. And there would be a similar here, but we can't go there because this would be negative percentages, which is not going to make any sense. So here's the model. It says find the concentration if you put in 10 milliliters. So if we put 10 in, 10 plus 20 is 30, we get 4 milliliters of acid in 30 milliliters of total solution. So the percentage is 4 out of 30, or 2 out of 15 times 100 to make it a percent, and that would be the percentage concentration. And what if we wanted to get a 4% solution? 4%, 20% was 20 parts in 100, or 1/5. 4% is 4 parts in 100. So if we're trying to get 4 out of 100, N would obviously have to be 80 to make a 4% solution. So we'd have to add 80 milliliters of water. And D, what happens is N gets large. As N gets large, this gets smaller and smaller. We're going to dilute the solution. That's what it means when you add water to get the percentage that's acid to decrease to near zero. Just keep adding water. So that's 45. Now for 47, I am going to do a separate video because it's kind of complicated what I want to talk about on 47.